Right, hopefully we are live now. So welcome everybody to Lambda Lounge November. Um, so this month we're going to have a talk from Hakeem about Carp, which is kind of like a Lisp Rust crossover kind of thing. Like the previous one we had where we explored Unison. We're going to just have to play around with it. Actually, why am I describing your talk for you, Hakeem? You go. You describe the talk.
I know you're doing very well. Thank you. Do you oh,
Oh, no, that's fine. I'm not as organized as James, so I don't have like a logo or whatever to say this is Lambda Lounge. But yes, it's Lambda Lounge
okay,
November, so go for it. Yeah.
excellent. So, hello. This is, as Connor said, this is Lambda Lounge. Would you like to share my screen?
Yeah, I will do.
I think you can do that. Thank you very much. So, hurrah! So, Carp
I'll
is
duck myself out now, so you go for it.
brilliant. Okay, hi everyone. So Carp is a Lisp, and I am not actually a Lisp specialist. I have done some closure in one of my day jobs for about a year, so I've got some experience using Lisp in industry. So the whole point of these sessions is not, and kind of quite deliberately not, us going, behold this wonderful information from on high. It's kind of taking an opportunity to look at an interesting programming language that maybe we wouldn't have spent a lot of time working on because there aren't currently jobs available in it. It's sort of alpha beta technology, and we think this might be interesting upcoming. So I've been looking at it for the last couple of weeks, kind of on and off, and so I'm only really kind of maybe a week ahead of some of you, and I just see that Eric, who's the author of Carp, is online, so obviously very, very far behind many others of you. So I'm hoping that you will make comments on either the YouTube channel or on Discord, which my colleagues Connor and James are going to post out on YouTube as well, and they'll hopefully feed back those questions and sort of comments to me. So first of all, I've got a setup here with a text editor, which is Vim, and a lovely REPL with a nice Unicode emoji. This will be a Chinese ideogram. I haven't checked, but I imagine it has something to do with Carp. So because Carp is very early stages, it doesn't have a lot of editor tooling. There is some editor tooling, but I've essentially used Vim with the closure syntax highlighting. You might see the closure word down there, and Vim8's terminal, and so I can basically send a Lisp form over to the REPL. So I've got here io.println hello Lambda Lounge, and I'm going to send that to the REPL, and you can see it's a little bit different from a standard Lisp in that it's compiled to out untitled, and it paused a little bit while it did that, and then it printed that out. So before I carry on with that, Tim Gabriel has pointed out on YouTube, join us on Gitter later, and Eric's asking for a link. So if somebody can post that link on the YouTube chat, perhaps James could also post it on our Discord as well. So the Carp team have a Gitter for chatting about Carp development, which is a really nice friendly place. They've been really helpful while I've been learning about it. So we noticed that it was compiling stuff, and I think so it compiles to C. Now, again, I'm not a C developer by any means. If you type cat, it actually will give you all the C that that's in the currently compiled file, and I was hoping that I might recognize some of these things here. So a lot of these are kind of library functions like min and max, and here you can see our main function, and it's generated a string, hello Lambda Lounge. It's created a reference to it. It's calling a function io.println with that reference. It's setting a return value and then returning that return value. So kind of that's all nice. And and I forget how to get out of there we go, how to get out of the Vim's terminal thing. I've never played with Vim 8's terminal before, so it's all very exciting and new. So so it's a Lisp that compiles to C, and you can imagine that Lisp, generally speaking, will be sort of dynamically typed or sort of weakly typed language, and of course C very much isn't. And if you looked at the C output, it's very much kind of C-like. It's not kind of wrapping it with a whole load of stuff to cope with that dynamism. And the reason is that everything is strongly typed within Carp as well. So I'm just going to sort of go through some of the basic things that I tried, and we can kind of see what worked and what didn't work. And again, please do comment anything that you'd like me to look into, any directions. I'm totally happy to go off on a wild tangent, but I've got some stuff prepared in case you're shy. But please do chat. So as you can see, Lisp has got, if you haven't come across Lisp, it's in parentheses, you've got a function keyword, and you've got all of the arguments. So this is defining a symbol called x, and it's giving it the value 1. I'm going to define that. I'm going to try and define that, and oh dear, oh dear. So I think I may have to restart that. Oh no, I don't want to do that. Okay, hang on. If anyone's used Vim 8 terminal, if they can let me know how you stop scrolling mode, that would be great. I'm frantically Googling that now. So it's Control-W-N to start it, and then I or A to resume as before. So look, there we go. Lovely. Okay, and okay, there we go. Brilliant. So I've defined a symbol called x. Apologies for that. And I'm now going to try and find out what the value of that x is. And as you can see on the right here, it's telling me that x is an integer. And it was defined in the REPL. This isn't what I expected. So another nice thing that I found is the id function, which you can see here, takes a value of any type, A, and returns a value of that same type. So obviously it's the ID function. And this I found is quite useful in the REPL because I can call id x, and you can see again it compiles that and it gives me back that value that's in there. So again, really simple hello world stuff. The addition operator in Carp is plus, and again when I call that I get another weird error, and this is all to do with the fact that you're mixing a Lisp, which is really dynamic and has macros and can edit stuff with, can edit the structure of the code that you're typing in, with Haskell, which is statically typed and very kind of rigid. Essentially, this is a kind of call that can't be resolved in the REPL. It would work totally fine in the context you're actually kind of normally using code in. So generally speaking, what the easiest thing to do is to use let bindings. So we're actually kind of working with variables in a particular scope. So this is saying let x equal to 1, and now in that scope evaluate this form with plus x and 1. And if I run that, you can see that it gets sent over to the REPL and it gives me the answer 2 without any problems. So generally speaking, Carp is really nice with the REPL, so the read eval print loop, the command line on the right, but it has a few kind of differences compared to something like Clojure. So going to get back to my thing there. Okay, yes, live coding during a presentation, brave. Yes, absolutely. I'm trying not to do too much live coding, so I've prepared a few bits here and there. So I mentioned that it has a little bit of the Haskell kind of strongly typed nature. And here, for example, if we wanted to define coordinates, so x and y coordinates, so we're defining a type and we're giving the subtypes of that types as well. So x is an integer and y is an integer. And again, if I run that, then we can inspect this point thing as well. And you can see that it's done a whole load for me for just that one line of code. It created an init function. It's created some setters and getters for x and y, and some update functions and so on. So really nice. So I can now create one of these values using point.init, which I mentioned. And again, you can see it compiles that executable and it returns me a value of type 0.12. Of course, this made me think, can I just type 0.12? And it doesn't understand that, it doesn't like that. So again, I think I'm going to skip some of this stuff here. Essentially, if you try to use globals, you end up in this having a whole load of fun where you have to pass a whole load of symbol soup at these things to make them work. Now, very briefly, because we may come across this later, the at is a reference, and the ampersand is referencing, and the at is dereferencing. So that's essentially referencing and dereferencing, which should be a no-op. Essentially, it's making a copy of that thing, and you get yourself into all kinds of conniptions. And the fun thing there is, because I don't know Rust, which uses a lot of these same concepts, you end up adding a lot of ampersands and ats kind of at random, hoping things work, and that turns out not to be the most efficient programming strategy. So if anybody desperately wants to see me choking and flailing around with that, I can go through those things. But I think it's more interesting to get to a bit of real code, just using local variables with let, where we have less of these problems. So in this case, I'm creating a point with a x and y of 1 and 2, and I'm going to then run set x on that, and that gives me a point with the x being 3 and the y is still 2. And as you can imagine, that's a copy of that. And you have very similar things to enclosure. You can update one of these fields with a function, and you can see I've given the reference to the function. So dec is the decrement function. So let me see whether this will work. Let's try decreasing 2 just to. There we go, and that gives you the answer 1, which is nice. And so again, this here will take that x of 1 and it will decrease it to 0.02. So you also have this threading macro, which is very similar to what happens in closure. And essentially, so let me delete that for now. And this code here is going to be exactly the same as the above. So that's going to take the p, which is a point with 1 comma 2, and it's going to call point update x with the decrement function on that. So that's exactly the same. So you might think, what's the point of that? And of course, it becomes useful when you want to chain a load of things. So here I'm going to decrement x and then decrement y. And you can see there 0, 1. So both of those fields have been decreased. And this is another example using the PRN function. Again, I'm not quite sure why that's happening. Vim's. This is a Vim problem that it occasionally gets into. There we go. So if another nice thing about the Carp REPL is it does tab completion. So if I get to P, I can tab complete it point.prn, and it gives me some. It tells me where the symbol's been defined and also any documentation that's relevant. And you can see here that the PRN function takes a reference to a point, and it returns a string. So essentially that's giving me a string representation of that point. So if I comma a, yeah, I mean, it looks exactly the same as before, because presumably the REPL already changes that into a string representation. And you've also got the ability to, so these things are essentially creating copies of the point. As you'd imagine, a lot of functional languages tend to be immutable and immutable by default. And so when you have an exclamation mark in here, that will actually change the variable, will mutate it in place, at which point when I refer to that p under there, it will have changed. So let me just run that. And again, you can see that's now actually edited that memory in place. Okay, so yeah, so James has just linked to the Carp Gitter on the YouTube channel, so you can head over there to ask the actual experts more about Carp after this. And yeah, as I say, really friendly channel. Also, while you're there, James, please do post a link to the Lambda Lounge Discord. So you should also join that. And there we talk about any functional languages and programming language theory. And okay, great. Oh yes, and Veit mentions Veit Heller is the main standard library maintainer who wrote the first blog post about Carp that I read, written a series of blog posts which are great. So yeah, they're here on YouTube and on Gitter. Hopefully will join us on the Lambda Lounge Discord later too. So this is an example from the Carp docs. If 1 equals 2, then maths is broken. So let's, fingers crossed, place your bets now. 2020 has been a hell of a year, but let's assume that everything's okay. And what's going on? I seem to have broken. I've broken everything. There we go. So the editor tooling that I'm using is parinfer, which is really nice when it works, and essentially means that I don't have to worry about parentheses at all. And this is largely because I was too dumb to use paredit, which is the one that I think the real serious Emacs Lisp people use. Paredit's nice. You tab it correctly and it pretty much usually works, except when it doesn't. So I'm going to run this. And you can see that maths is in fact fine. So this is good. So this isn't going to surprise anyone who knows anything about this. Oh, some love for parinfer. Thanks, Tim. But what's interesting, if you're not a Lisp programmer, is the way that all of this looks very much the same. You've got a list. It contains a token if, it contains a parenthesized an S expression, another S expression, another S expression. There's no kind of thens or elses or other types of there's very minimal other types of parentheses. You can see a little bit further down, you've got a couple of square brackets just to, sort of mix things up a bit. But classic Lisp doesn't even bother with any of that. So another nice thing you can do because of that sort of homoiconicity, i.e. everything is the same kind of thing, every symbol is basically the same, is if doesn't care about evaluating. So if isn't a statement in Lisp, it's just an expression. So here you could write this as well, print the result of calling if on is 1 is 2 and just return strings. This is the yes string, math is broken, and this is the failure string, maths is fine. And again, this is going to work just great. Maths is fine. So we have some nice for each statements. For each is a macro, and here we get to the bit that absolutely broke my brain. You can see some beautiful, not C this time, but more Lisp code in the REPL there. And of course, you could now try copying all of that and running it again in the REPL, and it, I think in this case doesn't work, but in other cases does. And this is for hand-wavy implementation reasons, again to do with the static and dynamic split. Essentially, it's easy enough to work around, as if you define a function like so. And again, I'll just sort of let me just show that function. You can see that it's a function that takes no arguments and returns no value. And if I call that function, then that will go over the list. It'll do for each x in 1, 2, 3. It prints the line with x1, x2, x3. Okay, Vite says, sorry for breaking my brain. This will be fixed, so hurrah. And I mean, interestingly, having discussed it, I can kind of see sort of why it happens. I don't understand the details by any stretch of the imagination. So, as you can see, I've got a not especially impressive section on macros here. And again, this might be something that could be fun if anyone wants to, wants us to live code an exciting macro. We can attempt to do it. I don't know what your idea of fun on a Monday evening is. So this is defining a macro called my increment, and it's going to take a parameter, and it's going to return a list with a plus, a 1, and an A. And this is actually where that whole macro evaluation thing comes in really useful, because if I evaluate that, and then I try to call my increment 1, you can see on the REPL that it's actually just returned what that resolved to. So it's returned the list with plus 1, and of course I passed in the number 1, so it's returning a 1 there as well. So again, ways you could run that. You could I think you could wrap it in id, for example, and that will give us 2, or you could run it in a function. Again, if you're running it within your main function of an actual program, you don't come into these problems. Essentially, for doing a demo, I thought the REPL is the right place to kind of be, and so that's what I'm doing. So that in a way, I've kind of made things a bit hard for myself. So I'm going to pause and drink some water. And okay, so I suggested, how about a little catter? And I can see a comment here, a remake of Velt brainfuck interpreter. I suspect that's not going to happen in the time I've got here, also because I don't know the syntax or semantics of brainfuck really very much, but thank you for the suggestion. So if anyone has a suggestion for a kata, so a very small problem that we could try and solve, together, i.e. me, with some helpful comments from all of you lot, please go ahead. And I do have one, if no one has any ideas, which is Roman to Arabic converter. If someone passes me a brainfuck spec and we think we can manage it in about half an hour, then by all means we can go for that. But have a think. So I can see in the backstage studio there, Connor shaking his head sadly, but I don't know if that's a brainfuck or Roman numerals.
I'm just disappointed that we can't rise to the challenge that commenter suggested. It's really good. We all love S-langs here at Lambda, so it's a really good suggestion, but we just don't have time for it, I don't think. Sorry.
I mean, we could maybe we could try and live code it another session, maybe with a bit of preparation.
Maybe. I mean, to be fair, I think there's probably funnier S-langs we could do rather than brainfuck. But yeah, maybe.
Okay.
Yeah.
So should we do a let's write an ESO-lang session sometime in the new year? So definitely we could do that. So I think unless I hear any other suggestions, I might go ahead and do some Roman numerals. Well, we can do brainfuck. Oh, so Vite has already done it. So Vite, perhaps you would like to come and do a talk at Lambda Lounge in the new year. I think, do we have February free, Connor? Yeah, I think White House February. Have a think. We would love to host you, and I'll happily come and help or ask stupid questions or something if that would be useful. We can write it in Carp. There we go. That would be fun. But I think I'm not going to attempt it today. So I'm going to go with Roman to Arabic converter. We might not get to the end of it. I mean, obviously I've got the code at the bottom there, but I don't want to just evaluate it because what's the fun in that? Let's actually write it. So anybody want a refresher on Roman numbers? So this is 1. Obviously, you know, if you add i's, you get 1, 2, 3. V is 5. And you can add them to there, so you've got kind of 8 and so on. Obviously, to get 4, you can't just do I because that would be madness. So instead, you subtract 1 from 5. We've got tens. We've got obviously multiple tens, and hundreds and thousands and so on. So I don't think it matters too much, kind of. Where we go there. Obviously, there's a whole load of interesting things like could you subtract 1 from 1,000 to get 999? And the implementation that I've got below does let you do that, but in fact, it should be something like DCCC. Anyway, it's a bit more complicated. So so there's all kinds of validation that you could do, and I'm not going to attempt to kind of make it all nice. But what we can do is start off with some let bindings, and we could define some. Oh, there we go. So thank you very much. There, that is 999 in Roman. So next time you have, I don't know why you need to know this now, but it comes up in katas. So one thing we might want to do is create a mapping of all the different numerals, and one thing that Carp has is a nice map literal syntax, so you don't have to. In fact, the first version I did of this was, I think I did a map from array, and then I had to do an array, and it was all very, very complicated. Actually, there's a nice syntax here where I can take a character, which is a backslash and the letter, and I can map it to a number, and I'm just going to return that value just to see what it's like. So if I run that, you can see that we've returned a dictionary with /i mapped to 1. So I mentioned that it's wrongly typed, so I'm going to try this. I haven't actually tried this, but I'm going to imagine that this isn't going to work, and let's see what. Here we go. I can't match the types int with a reference to a string. So apparently this is a reference to a string, which is nice. Okay, fun fact, the literal syntax is a reader literal that compiles to map from array, as I expected, being a Lisp. So there we go. Ooh, this is the bit where parent occasionally gets a bit confused. So we're gonna, okay, let's do that. So I'm gonna, you know what, I've done this already. I'm gonna just copy it. Okay. So we might have a function, convert, and functions take an input, which is going to be Roman. So define that, and if I want to call Roman on IX, for example, not called Roman, it's called convert. You can see that at the moment that just returns the map, hasn't returned anything useful yet. So we could instead return the return the actual string that we passed in. Oh, and you can see there that there's a warning. I don't know if you can see that very well. Let me just highlight that. That's not any clearer, but it basically says definition has changed type. So it used to return a hash map, and it's now returning a string instead, like so. So one function that I used was string.chars. And again, let's try running that. And string.chars basically explodes that string into an array of characters. And then what we could do is map over the numerals syntax. Now, so we could now do well. In fact, let's do one of these lovely threading macros. So we're going to take the Roman input, which is that string. We're going to call string chars on it. Let's just check that that still works. Yep. And then we're going to do an array map. And so again, I forget what you can see. Array's got a whole load of oh no, array maximum. Oh, is it? So array map is going to do a copy map. So copy map is maps over an array using the function f. It copies the array. You can instead use endomap if you wanted to do change it in place. I'm going to go with copy map because again, functional programming. So I'm going to copy map. I'm going to need to pass in a function, and then I'm going to need to pass in the array, which means you need copy map if you want to change the type. Good point. So in fact, let me just, if I typed array.endomap in the REPL, you can see the type of element cannot change. So because I want to change from a character into a number, I definitely need copy map. So the other thing is that because of the position of the threading macro, I need to use the double thread like so. And so I want to pass a function. Now in Clojure, you can use an array, you can use a hash map as a function. I don't think you can do that here. It doesn't look like it. So I'm going to create a function called lookup, which is a function that takes in a char, and it's going to return map.get. Map.get takes in a reference to a map and a value, and it returns a reference. So if I do map.get, I'm going to take a reference like that, numerals, char. Yeah, okay, let's see if that does anything. Oop. So I can't match the types map and function within array copy map. Copy map takes a function which is numerals. Okay, I'm very confused. So I might sneak down here and see what I've written before, because I've already done this. Map.get numerals char. That looks very much so. Copy map. But oh, because yes, of course, I'm still referring numerals. Thank you. Tim's just said the same thing there. So there we go. That was just me being dumb rather than a massive conceptual problem, which is always nice. But it can't match the types, an array of char and a reference, and that might be. Let's have a look. Arabic. Okay, yes, I need to it's expecting a reference to an array of jars. I need to type in ref there. So this is the kind of stuff that possibly if you've used Rust already, you'll have a much deeper intuition over where you're putting these things and where you're not. Usually, if you see a message there which is unreadable, my color scheme isn't very good, and I'm not going to try and mess about with Vim's color scheme on the fly because all bad things could happen. Essentially, I can't match the types array of char with the reference of to an array. So I've added that ref in there now. It warns that the definition has changed, and I'm going to run that function there. And you can see we've now returned an array with the number 1 and the number 10. So that's looked up I is 1 and x is 10. So we're doing great. So the easiest thing to do would be to just literally add the digits up together, and I think I should probably do that, because if you imagine this one here, xi, you can see that if you added the 10 and the 1, you'd get 11, which is the right answer. So we should ignore the subtractions for now. Here we go, right, saying it does get better with borrow checking, which is good. And yeah, just in the last couple of weeks using it, I've become slightly less frustrated. This might not be obvious, but it was definitely much more painful before. So we could now do a reduce. Well, let's see what the just check the syntax of that. So reduce takes a function, a 0, and the x's there. So yeah, so it takes the function. I find these type signatures still quite difficult to read because of the amount of parentheses. It's quite hard to see where the output value and the input values are. Obviously, you can see that you start with a square bracket and you get to the end bracket there. That's all the same kind of that's all the input and that's the output. What's complicated is that you also get extra parameters there which aren't types, and they are lifetimes. And again, this is sort of Rust stuff that hasn't been a problem apart from slightly making the type signatures a bit harder to read. So, but this has actually got a sum function here. So you can see there that there's we're defining. Let's just, in fact, define that function now, because this is basically like an add function, isn't it? So if we define add, oops. So if we were to add 1 and 2, that doesn't work because it's, you can see there's an at, which is a dereferencing, so if we add 1 and a reference to 2, we get 3. And so this is a bit weird because you can imagine that you could have just used the plus, which is called int.plus, and that takes an int and an int, whereas add takes something that's addable and a reference to something that's addable instead. And the reason for that is going to be how reduce works with referencing, and that's why we're having to create this function here. So if we call array.reduce with our new function add over that, the wrong number, of course, because I need to have the 0 to it as well. And I'm going to assume, so you can see there again, can't match types array and ref array. I'm going to assume that there's another case of having to reference that. I don't know why I'm saving. I just need to. There we go. So now when I convert xi, I get 11. So we're now basically handling about 80% of Roman numerals, which is pretty good. And I think I might show the rest of the code rather than trying to do it, because I'm not sure if the process of going through a Roman numeral kata is necessarily all that much fun. I've been doing this all for the last 2 weeks actually. So at work we're running a coding challenge, and people are submitting versions of this Roman numeral kata in Go and Rust and JavaScript and Python and so on. And it's been quite a lot of fun. Okay, yes, so memory copy stack if it's a stack variable, and heap if heap allocated. And this is where, being a high-level programmer, for the most part, not having done enough C, I don't have a very strong mental model over why I should care whether things are on the stack or the heap, probably to my shame. Okay, Connor's saying, I hope you mark down the people who used Go. They are on my naughty list. A couple of people use Rust. In fact, the Rust solutions look quite complicated, and I don't know whether that's partly because of the lack of familiarity with the borrow checker, and that somehow it tends to make people go down strange paths in order to get to where they're going to. So if you look at here's one I wrote earlier. And you can see that I've got this. This is what I did before I discovered the pair literal. Someone pointed out on the Gitter that creating a hash map from a list of tuple types of pairs. And I've got this nice sum digits function, which essentially adds digits up. So it takes an array like 1, 10, well, let's do kind of 10, 100, 1, sort of 5, 1, for example, and it'll check whether there's more than 2 items. If there are, it'll see whether one can be subtracted from the next one. So in this case, 10 minus 100 is going to be 90. But then after that, 90 and 5, you can't be subtracted. So we're going to add that one, and we're going to add the 1 as well. And the whole thing then becomes 96. So essentially, that's what we're doing there. Is we're going, if we've got nothing left, we're going to return the accumulator. If we've got 1, we're going to return the accumulator plus the value that's there. If we've got more, then we'll do a comparison, do some summing, and then we're going to take a slice of all of the rest of the digits. And I think this is in a way, this would be easier in a classic sort of dynamic Lisp in a way, and possibly will be easier with pattern matching, which I may well have missed in Carp. So this is probably a terrible solution. And also thanks very much to everyone on Gitter for helping me while I was trying to get to that. I got lots of so these 3 characters, the 2 ampersands and the at there, took basically blood, sweat and tears to get them in the right order and not have them in the wrong places. And, so all good fun. So if I evaluate that though, and evaluate the version that I wrote before, which calls that sum digits function, you can see that I can even handle this kind of rather unwieldy looking thing. Any guesses very quickly? YouTube comment on what is that number? No cheating. Okay. Oh, you're all too slow. See if you can beat Carp. No, so that's 1999. So I think that's been 45 minutes of random Lisp semi-live coding, and it would be really good to hear if anyone has a direction they'd like to go in, or any other comments? Oh, I can't hear you, Connor.
I was going to say, while people are thinking of their questions, I've got a question.
Oh, yes.
Maybe you can talk a bit about the kind of motivation behind Carp. I think it's like kind of for games, is that right? Or what's the rationale, I suppose?
So I was trying to explain to my partner earlier, who's a bookseller, and the idea that if you have your bookshelf full of books and you need to rearrange it, you could, your manager in the bookshop could say, move this book from shelf 3 to shelf 2, move this book from shelf 3 to shelf 2, or they could say, can you tidy up the kids section, please? And so those are essentially the same differences between high-level languages that do very sort of fast and loose memory management, and low-level languages where you are in charge of all the nitty-gritty details about which books go where, which data goes into which sections. Don't know whether that's interesting to anyone. I think sometimes it's hard for us techies to describe complicated concepts to our partners, friends, and family who don't come from that background. And I quite like trying to find metaphors for that. And I think that Rust and Carp have their ideas to try to get something with the speed of doing manual memory management, where you're very explicit about when do you shift memory from one place to another, release memory that's no longer used, compared to nice high-level languages where you just don't need to bother about that stuff until you get a memory leak in production and it's horrific, and you're on call for the next month. So both the approaches have got disadvantages, and I think Rust is trying to form a kind of a middle path where you don't have the slowdowns of having to worry about that all the time, and you don't have the ability to shoot yourself in the foot that you do if you're writing something like C. I think that's the kind of motivation there. And so in the case of Rust, it tends to be targeted for very low level systems programming, where you can't afford to have a garbage collection to automated memory management run kicking in at the inappropriate time and slowing everything down. And as I understand it from Eric's original motivation for Carp, the other fields would be things like multimedia and games, as you mentioned, and audio, where again you don't want to be playing some audio and then suddenly garbage collection comes in and your audio is stuttering and it's no good to anyone. So this idea of being very clear about who owns which piece of memory and where, when can it be got rid of, and who is allowed to change it, has these magical properties that really, and unfortunately, my examples don't go anywhere near to really motivating. But I think that's the reason. Now, I did manage to compile some of the SDL code. Obviously, it's not in my Vim window, and it ends up with an example that Vite had of a line being drawn. So I don't know if it's that impressive, but I can show the code. Now, there's another questions come in, I think, in the meantime. I thought I saw a question. Here we go. How do Carp and Lux slang compare? They seem to be in a similar space. Now, I've not heard of Lux. I'm going to put that in Vim. If somebody could put that on the YouTube channel as well, that would be great. That is a functional statically typed Lisp that will run on several platforms, such as the JVM and JavaScript interpreters. So I think that's probably one for the core team here to answer if they have any ideas. So hopefully someone will give an answer, and we'll share it on YouTube. And if not, again, they'll be around later on Gitter. Okay, so that's the Lux slang there. It occurs to me I could do this on StreamYard as well. Never mind. Cool. So let me show an example of this code. Again, I think I'm not going to run it just because it literally draws a line. But there's a couple of really nice things here. So load, this would normally be written if you've got the package installed, something like this. You'd load the library with a string, but especially within the REPL, I think it seems quite safe to do. You can literally put in a GitHub URL, presumably any Git repo URL, and that loads the library in, and then we have a draw function that draws a line from one corner of the screen to another corner, and that's literally just in a few lines that creates a nice pop-up window with some SDL drawing. So if you have a look at the Carp language website, you can see there's a list of libraries, including this SDL. There's a basic SDL wrapper and this Anima one, which is more of a wrapper with some of the capabilities of processing, which is a popular creative coding library. So again, open invitation to Veit and Eric and anyone else, if you want to come and demo some of the cool, more advanced features of Carp sometime in the new year, that would be great. So comment from Tim, which I'll read out as well. So the main reason he uses Carp is that it compiles to C, so it can run pretty much everywhere. I use it to program MCUs and make GBA games. And somebody could explain what MCU and GBA are.
GBA is Game Boy Advance, I presume. I don't know what MCU is.
Ah, brilliant. Game Boy Advanced. Fantastic. So yeah, no, I mean, I love that, the idea of Lisp being used to make actual games. So it would be really fun. Tim, again, open invitation. If you'd like to demo some Carp games in the new year, then please get in touch. That'd be amazing.
Cool. So I think, unless there's any other questions, that we probably wrap up pretty soon because we're coming on to an hour.
Mm-hmm.
Yeah. So
James use microcontrollers.
Ah, there you go. That explains it. Yeah, I've never done any embedded stuff, so I wouldn't have a clue. But I imagine that in like a constrained environment like that, where the memory is quite constrained, you probably need to get the most efficient code you can. So makes sense.
Yeah. Oh, that sounds great. So can you target Arduinos with that? And are there good libraries for that, Tim? Well, again, maybe you can answer that here or on Gitter later.
Yep. So yeah, thanks, Keen. That was cool. So yeah, let me try and share this. Yeah, I'm gonna try it. It's gonna work. Yes. Hey, no. Oh, fuck it. It's wrong. Yeah. So basically, thanks very much for coming. The text has vanished. I don't know why. But wait, oh no. Yeah, there we go. Yay. So there's a link just to our Lambda Lounge Discord. So please come and join us. You can scan that QR code apparently and join us. And yeah, we'd love to chat with you on Discord. Yeah, come hang out. I think next month we're not going to have a meeting. We don't tend to have one in December, but we'll be back in January with a talk from Michael Arnaldi about the TypeScript MATEX effect library. So that should be really cool. So yeah, hope to see you there.
Cool. Thanks very much, everybody.
Cheers. Bye all.